morning, everybody. So we are going to start the class, and we are going to end this class by 10 today because of the time and now starting by 10. So that's when we are going to end the class today. So we are going to talk about Datatype today. So how to build so building your first Datatype. So that's what we are going to briefly talk about for today's class. So this is the sequence of a standard linear regression or machine learning problem. So the first step is to load the data. So the data is actually from a CSV file, it can be from a text file, it can be an Excel file, or if it is an image, it can be a folder of images. So that's the first step. So the second step is to clean the data. So cleaning the data just involves removing unwanted, it just simply means removing unwanted data that is not supposed to be there. So in our case, for the last class, for the last data set we used, which is the auto MPG data set. So we saw that there were some missing values in the data set. So, and the missing values were like showing as question mark. And the data set cannot, the machine learning algorithm, if we feed it directly and use it to build the model, we'll see that it's not going to be, it's even going to give us error. We're not going to be able to do anything with it in terms of building the AI model. So that calls for cleaning of the data. So the data has to be cleaned. Another thing you have to do is that when you have a data set, you have to visually inspect the data. So for instance, if the data is given in Excel form, you cannot just turn a blind eye and say that I don't even need to look at the data. You have to look at the data and actually see the structure, because that is what will enable you to build a more robust model. Then the next step we talked about is pre-processing the data. So we have to pre-process it for several reasons. So one of the reasons we have to pre-process it is that when we do pre-processing, the deep learning model or the machine learning model will develop when the data set is pre-processed is better, it performs better than when the data set is not pre-processed. Then one pre-processing step I talked to you about is standardization. So that's pre-processing step. So I showed you a histogram of some of the columns in the data set, and they were the ranges of those columns, of those attributes. They were really far apart. They were not really very, some was between 0 to 10, some was between 1,000 to 5,000. So they were in different ranges. So we want to bring everything closer to each other, because we find out that when we do pre-processing, the deep learning model performs better and it converges faster than when it is not pre-processed. So we talked about, in this case, we talked about categorical attributes, and we talked about continuous attributes. So those are the two kinds of features we talked about. So for continuous attributes, so we said that they are in numeric form and they are continuous in nature. But for categorical attributes, they are also called discrete attributes. So they are into categories. So the way we process for continuous is different from the way we process for discrete. So after that, you need to build the dataset pipe or the data pipe. So, and this is what this lecture is. This is what the class we are going to be doing for today's class. So building the dataset or data pipe, it actually involves, you already have the data set and you already have the columns, but we want to know what are the targets. So the target means the output. We want to know what are the attributes, what are the continuous attributes, and what are the categorical attributes. So we are going to build a data pipe in which we have the output or the target in one instance or in one column, and we've already categorized it into continuous attributes and discrete attributes. So it's actually building a structure by which you are able to conveniently feed into your AI model. So in building data pipe, you are building the targets, you are building the data pipe of the targets, and you are building the data pipe of the attributes, and letting the AI model know that this is the target, this is the output, and these are the attributes. So these are the attributes, either continuous or categorical attributes. So you are just trying to build it in a more formal way so that the AI model recognizes what it's supposed to do. Then building the data loader is simply all of the data set. We are not going to put it into the AI model at once. You are going to be loading it batch by batch. So building the data loader just simply means that how are you going to load it into the AI model. And of course the model. So the model involves defining the input layer, the number of hidden layers, then the activation function. So if it is a non-linear regression, you have to put an activation function there. So it's defining all of these layers. That's what the building the model involves. Then defining the loss function. The loss function is really very important because when I defined machine learning, I said machine learning is to make predictions. So it's just used to predict. But we need to compare the predictions. We need to compare the predictions with the actual output. So if this is the prediction, then this is the actual output. We need to know how close or how far we are. How far is our prediction from the output, from the actual output, or from the actual target? And that is where the loss function comes in. So the loss function we talked about is mean squared error. So you get the error, you square it, then you find the mean. Then you will use that as a deciding factor to know how far the AI model is doing. So basically this mean square error, it should be as close to 0 as possible. So that's the loss function. Then defining the optimizer. The optimizer is simply what we use to update the weight of the AI model. So if this is like a linear regression problem that you have W1 X1 or W0 X0. So if this is the function, linear regression function. So these are the weights, and the weights are, first of all, they are randomly generated the first time, but the second iteration, the weights have to be updated. Then the optimizer is the algorithm through which these weights are going to be updated. So we talked about different types of optimizers. We talked about the gradient descent. So it was the gradient descent we talked about. Then there are other forms of optimizer like the Adam optimizer and so on. Then we looked at the training loop. So you are going to train the model based on all of this. So after training the model, you are in the training stage. So the model is developed, then you eventually use it to make predictions. So we've actually gone through all of this pipeline. We've gone through all of them last week, but we just want to consider another data set. So it was the auto MPG data set that we were working with. So we want to consider, okay. So we want to consider, yes. Okay, so that's a very good question. So it's when we did it in the previous example of the auto MPG data set, it was at this point. It was at this, after cleaning, before pre-processing, that was when we divided it into train, test, and validation. So we did it here at this point, but for this class, we are going to be doing it somewhere around here. So somewhere in between here and here. But the answer to your question is that no matter which part you decide to do it in, it must actually come before this training loop. So it must come before this training loop, because it is here you actually build, you actually develop the model. So here you are building the model, but still you can still be working with the model as a single entity. But here is where you actually, the model is actually developed, is now trained. So whatever you intend to do, just make sure that you divide it before you actually build the actual model. So that was a very good question. So thank you for the question. So we'll talk about so what we are doing for today's class is basically the same thing we've done, but we are going to consider another data set. So the data set we are going to be considering is the car prices data set. So let's look at the data set. So like I told you earlier, when tasked with a machine learning problem or a deep learning problem, yes? Can you increase the brightness? Okay, so like I said earlier, you have to do a visual inspection of the data set. So this is the folder. So this is the folder for the data set, car prices. So this is the folder for the data set. So if you look at the data set, it contains different car models, like the Audi, BMW, the Ford, the Mercedes-Benz, Toyota. So it contains different models of different cars. So that's what the data set contains. Then I opened this one. So when I open this one, this is the data set that you have here. So for each of these CSV files or Excel files, you have something similar that we have in the one I just opened, or exactly the same but different values. So in this column, you have the model of the car. This column is the year the car was manufactured. Then this is the price of the car in dollars. Then this is the transmission time, manual or automatic. This is the mileage. So the mileage is how many miles the car has traveled. Then this is the fuel type. Is it using a diesel or a petrol? This is the tax. So the amount that is going to be taxed on or that was taxed on that particular car. This is the MPG. So the miles per gallon, the fuel consumption of the car in miles per gallon. Then this is the engine size of the car. So this is the structure of the data set. So this data set is much more complicated than the one we did previously, because in the one we did previously, we're just combining, we're just working with a single Excel sheet. But now, what we are doing is that we are combining multiple Excel sheets together. So that is what makes this problem much complicated than the first problem that we did in last week. So we'll combine. So this is just for the so you have the one for different ones like the Mercedes, the Toyota, the Ford, and everything. So we want to combine different Excel sheets together and use it to build a single AI model. So for this class, our goal is to build a data type that produces a dictionary with 3 keys in it. So the label, the continuous attributes, and the categorical attributes. So I want to ask the class a question. So we've seen the data set. Let me try to make it okay, let me scroll down so that you can also see and just observe it, because I want to ask a question. So let me just scroll down. So you've seen the data set. So can somebody tell me what will be the categorical or discrete attributes and what will be the continuous attribute?
Model year transmission will be discrete. All the price, mileage, max, and MPG,
The target, actually, because we want to predict the price of the house. So let's leave out the price, because the price is the output. We want to make prediction of the price. So just remove the price, then tell me the continuous and the discrete. Mileage and MPG are what? Okay. Do anybody have any counter opinion or another opinion? Okay, so the model is a discrete attribute. The model is a discrete or categorical attribute. The transmission is a discrete or categorical attribute. So it's either manual or automatic. So it's that one is really simple. The default type is also a discrete or categorical attribute because it's either petrol or diesel. So the model, the transmission type, the foil type, engine type. Okay, the year. So I will still come to the year aspect. So the year can either be two ways. It can either fall to the continuous or the categorical attributes, depending on how you see it. So for the purpose of this class, the year, we are going to consider it as a continuous attribute for the purpose of this class. But in the lab, I will be telling you to change the year from a continuous attribute to a categorical attribute. Then try to compare the difference in terms of how the model performs. So either whether it's better, so the observation you'll be reporting is that is it better to put the year or to reprocess the year as either a continuous attribute or a discrete attribute. But for the purpose of this class, the year is a continuous attribute. So this is a categorical or discrete attribute. This is a categorical or discrete attribute, and this is a categorical or discrete attribute. Then the rest are processed as continuous attributes. So this is a visual inspection of the data set. Then also, like I said, this CSV file is just for one type of car. So you have several CSV files here for different brands of cars. So the reason why this exercise is more complicated is because we want to combine different CSV files. We want to combine it together. So we are going to, so the first step, so now we've looked at data sets and we've already known what we intend to do. So the first step is we are going to be using this library. So you have to install the library. So I've already put this code, the Google Colab code on your module. So if you have the module, if you have your computer, then you can also follow along. So this is the installation of the library that we need for this task. Then this is, we are going to do this importation and this command to prevent errors based on the touch data library. Then this is the data set we have. So we can see that we have, these are the files in the data set. So these are the files in the data set. So it turns out that they are unwanted files that are in the data set. So like this is a car model. From the name you can know that this is a car, 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 this is a car. This and these are car models. But the others, CC, unclean, they are not car models. So we have to do some cleaning to remove the unwanted classes. So it's not every of the CSV file that we are going to load and we are going to use. So we are going to remove the ones that are not car models. So that's why, like I said, you have to do a visual inspection of your data set, because you cannot just, once you have a data set, you cannot just like load it directly without even looking at it. So one reason you need to do a visual inspection is for the purpose of data cleaning, to know which one you are going to remove, and also to know how you are going to, which one are the discrete or categorical attributes and which one are the continuous attributes. That is why it is very essential to visually inspect your data set. So we have these CSV files that are not car models that we need to remove. So you know that we need to remove them. Then all of the CSV files has this column. So this column are the attributes. Then I said that the task for this AI model is to predict the price. So the price is actually the target. So the price is the output. So this code here is to get the data set from this URL. So it's just to, so the data set is from a URL. So it's to get the data set. Then after you get the data set, you have to unzip it, because the data set is actually a zipped file. So when I downloaded it, so this is actually the zipped file. So you can see that the file is zipped. So you cannot just work with zip file, you have to unzip it. So that's what this line of code is doing, to unzip the data, is to unzip the file. So after you've unzipped it, you would see the different CSV files that are contained within the data set. So after unzipping, if you click on this folder icon, on this file icon in Google Colab, it's supposed to, you are going to see the folder, you are going to see the zip folder, and you are going to see the unzipped folder. So it's because I'm not connected I'm not connected to a runtime. That's why it's not displayed. So in this portion, you are supposed to see the folder, the zipped folder and the unzipped folder when you go to this file section here. So we've unzipped the file. Then we need to build the data pipe, so consisting of the output or the target, then the continuous attributes and the discrete attribute So we are going to build, like I said, the task for today is to build a dictionary, or to build a data pipe with 3 keys. So the label, which is the output, the continuous attribute, which is stored in this, then the categorical or discrete attributes, which is stored in this variable. So that's what we intend to do. So we import this, then we include, so this is the name of the folder. So we start by defining a data type, that's the folder, and we put all of the contents of the folder into the data type, into the data pipe. Then the next step is we just want to see the contents of the folder, or the contents of the car prices folder. So we've seen the contents of the car prices folder. So when you look at the output and you compare it with what is inside this folder, then you see that they are the same name. So we just want to view the contents that are inside the car prices folder. So there are different CSV files. There are different CSV files. And like I said, we need to combine several CSV files together in this particular task. Then now, like I said, we need to do some cleaning. So after loading the data, so we've loaded the data, which is the folder. So we need to do some cleaning. So the cleaning that we are going to do is to remove the unwanted files. So I told you that some of the CSV files, they are not cars, they are not car models. So we want to do data cleaning. So this portion of code, this is a function, and the function is to remove the unwanted files. So we saw that one was named unclean, or it started with unclean. Another was started with focus. Another started with CC class. So this function is to remove everything that starts with this name in that car prices folder. So that's what this code is for. So here we are defining the function, and here we are actually applying the function. So this is the name of the function, filter for data. So it's to clean the data to remove the unwanted files in it. So this is the name of the function, then this is the code that actually does the removal. So here we are calling the function here. So here is to call the function. So once we've called the function, then here is just to view it after we've removed all the unwanted files. So when we do that, this is the output. So we can see that the unwanted files have been removed. So we just have original car models. So these are what we know that are car models. So if you compare the outputs here with what you have here, you can see that the unwanted files were still there. CC class, focus, unclean. They were there previously. But after we applied that function, so we can see that the unwanted classes have been removed. So this is called data cleaning. So we've tried to clean the data. Then the next step now is to read the contents, to open the files, to open each of the CSV files. So we want to open it and we want to read from it. So we opened, so this block of code is to open each of these files, then store it in a Datatype. So store it in a Datatype so that all of the contents in all of the CSV files, they are now contained in just one format. So because previously all of them are different files, separate files. So now we are just trying to join everything together. So here we are viewing the first 4 lines of the data pipe. So when we look at the first 4 lines of the data pipe, not the first 4 lines, the first 4 lines of the data pipe. So what this output it shows is, like I said, is the first 4 lines of the data pipe. So you have A1, A6, A1, A4, 20, 17, 16, 16, 16. So this is reading each of the columns in the data set. So let's look at the data set again and compare it. So you have A1, A6, A1, and A4. So when you look at the data set, A1, A6, A1, and A4. So that's why I said it's reading the first 4 lines of the data set. So we look at the results again. So for the year, so what this code is returning is just the first 4 lines. So these are the first 4 lines. So, and it's returning each of them as like a tuple or a list. So, it started from here and it ended here. So, if you look at what I've just highlighted and what's the output, you can see that it is the same thing. So it's reading it line, the first 4 values, line by line. Then the next step now is because actually the next step now is to include the name of the CSV file as a feature or as an attribute. That's the next step. The next step is to include the name of the CSV file as an attribute. That's the next step. So let me come again. The next step is to include the name of the CSV file. I will know that the name of the CSV file is the name of the car manufacturer. So be it BMW, Toyota, and all of those file names. We want to include it as a feature. That's the next step. So this function over here is to get the name of the CSV file, which is, in other words, the name of the car manufacturer. So we have like different names. When we look at that CSV file, there was like Audi, BMW, Mercedes, and Toyota, Ford. So these are the names of the CSV file, which corresponds to the name of the manufacturer. And like I said, we need to add it as an attribute. We need to add it as an attribute in which we are going to feed to our AI model. So that's what this function is doing. So here is to define the function in Python and convert it to an uppercase. So to convert the name of the CSV file to uppercase. So after defining the function, we now call the function. The name of the function is car manufacturer. So after defining the function, we call it this function here, because you cannot just define a function without calling it. So defining the function doesn't mean that you've called it. So here is to define the function, and here is to call it and include it in our data pipe, because like we said, we are building a data pipe. So after calling it here, the next step is just to view it. So this slide is just to view it. So let's look at the output. Yeah. So when we look at the output, you can see that this line here has been added. So can somebody tell me what this line represents? Yes. So this is the car manufacturer, because here we defined the code to call the car manufacturer. So the car manufacturer has already been included. And like I said, it is included as an attribute or a feature. So my next question is, we have different car manufacturers now. We have included in the data pipe. My question is, these car manufacturers, we know them. Let's look at it once more. So these are the different car manufacturers. Let's look at it once again. So these are the different car manufacturers. So let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the different car manufacturers. So my question is, these car manufacturers now, they've been included as an attribute. So this attribute, will it be categorical? or continuous? Yes. So why would it be categorical? How many classes? How many categories? 9. So we know that this is going to be categorical or discrete because we discovered that it's into classes and we defined it as 9 classes. So we have 10 features now. So why is it 10 features? So it is 10 features. So like I said, 1, 2, 3, 4, 5, 6, 7, 8, 9. The 10th one is the car manufacturer, which we've included. So we have 10 features, but we know that one of these is the target. So the price is the target and it's the output. So we are almost done. So the next step is to pre-process the data. Now, so we've done this before. So we pre-process the continuous attributes using standardization, standard scalar. Then we pre-process the categorical attributes as we would encode it. So we do some encoding for the categorical attributes. So what do we mean by this kind of encoding we want to do? Let's look at the data set again. So remember in the last class, one encoding I told you about is a form of encoding in which you have the categorical attributes. Then you try to generate some random values through a predefined Python function that will be like a kind of representation of that particular categorical attribute. So that's one method. But the method, we'll still use that method. But first, I want you to know that, let me highlight some of these columns. So let me highlight this column. Let me highlight this column and this column here. So these are the 3 columns I highlighted, and I said that they are the categorical or discrete attributes. So can somebody tell me these 3 columns that I've highlighted? You can see the values. The reason why they are different from the others is that the others are numeric, they are numbers. But these ones, they are not numbers, they are like alphabets, they are strings. My question is, can we feed in this data directly into our AI model? And if not, why not? So these 3 columns that I've highlighted, can we just feed it directly into the AI model? And if no, why not? That's the question. These 3 columns here, can we feed it directly to the AI model? So if no, why? Why no? Yes, so it's right, because you can only feed in numeric values into your AI model. It can only be numbers, because like this is the smallest model or the simplest AI model we came up with previously, and you need to perform some arithmetic. But on alphabets, can you do any form of arithmetic on alphabets? No. So that is the answer to the question, because these are not these are not our numbers. So any form of AI model that you'll be building, you need to do a form of conversion that will convert this alphabet into a kind of number representation. So that's what we want to do. So what the next step involves, actually you already have the continuous attributes that we are going to standardize, but the next step is how are we going to treat all of these columns. So we are going to do an encoding. So the encoding is just to get the unique values, and maybe we already know that this is two values, 0 manual, automatic. So we can just say this can be 0 and this can be 1. We already know that this one has two classes, petrol and diesel. So we can just say let this be 0 and let this be 1. So here we can just say let this be 0, let this be 1. So this one is 0. So let me try to do the encoding for you. So here is 0 and here is 1. Okay, there's semi-automatic. Okay, let's see. Okay, yes, thank you. Yes, there's semi-automatic. So that semi-automatic will be 2. So that semi-automatic will be 2. So thank you very much for that observation. Then for that, let's say this one is 0 and let's say this is 1. Then for model, if you want to encode it, this one will be 0, this one will be 1. What would this A1 be? 0. A4 will be what? 2. A3 will be what? A1 is 0, thank you. A6 is 1. A4 is 2. A3 is 3. A1 is 0, and so on and so on. So we still have, I think there's a O3 there, Q3. So maybe that one is going to be a 4. Yes, so that's how we are going to do the encoding. So let's go back. So let's go back to the encoding. So this one is just talking about the encoding. So actually, the foil type is not only 1 and 2. There are other classes. There is hybrid, there is electric, and there is other. So it was only 0, petrol and diesel I was saying, but there are other types. So let's look at the other types. Okay, for this, yes. Okay, look at, we can see hybrid. We can see hybrid here. I'm not sure there's electric. Let me search for electric. Okay, so electric is not here. So probably electric is in another class. Let's see BMW. So like I said, we've already combined all of these files together, all of these different CSV files together. So the Python, that's the beauty of Python code. So it will automatically knows the classes is going to, the different classes. Okay, so we have electric here in the BMW. So this here is just to do a form of encoding, so that I just described. Then of course, the encoding is stated there. So we defined a function. This is the function we defined to do the encoding for us. So this function was defined. It's called gen encoder dictionary. So it's this function that does the encoding for us. So it's not like there is a named it, but the explanation is you are just getting all the unique values as defined by this line, then just putting after getting the unique values, then trying to specify an index for each of the values. So the name is called Gen Encoder Dictionary, and after defining it, like I said, this is a function. We are just trying to specify it. So here is where we actually call the function, and we call it drop-down encoder. So it's just a form of encoding that we are doing. But the real encoding we are going to do is similar to the one we did last week, which is the ordinal encoder. So the ordinal encoder, based on each of the features, is going to generate random values that represent that particular attribute, which we are going to feed as features to the AI model. So after defining the encoding, the next step is to do some pre-processing. And the pre-processing that we are doing here is so we've not actually done the pre-processing, but what we are actually doing here, before we actually do the pre-processing on the continuous variables, what we are doing here is to define a function. We are defining a function called preproc. That's the name of the function. And what the function is doing is that, remember, the task for us is to build a data pipe consisting of a dictionary with 3 keys. So the 3 keys are the output, which is the label, the continuous attribute, and the categorical attribute. So what this function is doing is actually to build a dictionary with 3 keys consisting of the label, which is the output, the continuous attribute, and the discrete attribute. So here are the different attributes that we have. So it's already stated here. Then here are the categorical attributes. So the manufacturer is a categorical attribute because we can see that we have 9 classes. Then here are the continuous attributes. Then the target is the price. So it is the output. So we are just trying to do a pre-processing such that we build the target, the features, and the continuous attributes. So if we look at the data pipe now, we are almost done. So we are almost done with building the data pipe. So here we are trying to display the first 4 rows of the data pipe. So here is the target, the output. So if you look at, let's look at this BMW dataset or the Audi. So let's look at this dataset here. So here is the output, the target. So look at these values carefully. $12,500, $6,500, $11,000, $16,800. So this is the target. Like I told you, is the price you are predicting. So the numbers I just read from the Jupyter notebook, these are the prices. So, and it is the output. So we are building a data pipe of the output, which is the price, then the continuous attributes and the discrete attributes. So these are the continuous attributes. So this represents the year. So the first one is 2017. So it's showing like this. So the first one are the continuous attributes. So let's look at the continuous attributes here. So 2017, 2016, 2016, and 2017. So that's what is showing here. 2017. So it's showing the. So this is showing the year. Okay. So let's put it this way. So we've seen the continuous attributes. Now, let me show it to you again. So who has the Excel file opened? So this is the year, this is the model, the year, the price, the transmission, mileage, fault type, tax, etc. So the continuous attributes are the year. So this is the target, this is the mileage, year, the mileage, the tax, the MPG, and the engine size. So these are the continuous attributes. So here is the year. So what's this color? What's this color? So here is the year of the continuous attribute. So what is this color? Mileage. So here is the mileage. So what is this color? Is it MPG or tax? Tax. So here is the, I think MPG. So these are the different continuous attributes. Then this one are the different categorical attributes. So what with this color? What does it represent? Model. So we've seen how we did the encoding. This column, what is it? Transmission type. Transmission type. Then this one is what? Fault type. Then the last one is what? Manufacturer. So we have been able to build the Datatype now. So the last step is just to standardize the continuous attributes. So that's the last step, is to standardize. Yes? The engine size. Okay, this one's supposed to be engine. One, two, three, four. Okay, yes. Thank you. So this is the year, this is the mileage. Then so here is so is this one tax? Yes. Then there is what? MPG. MPG. The last one is engine size. So thank you very much for that observation. So these are the different columns, or these are the different continuous attributes we have. Then these are the discrete or categorical attributes we have after doing some encoding. So we call this, so you were asking for the name of the encoding. The name is drop down encoding, but it's not like standard, but it's just an encoding we defined just to convert the alphabet to numeric form. So yes. Okay, you see this drop down and you want it. Okay, table encoding. So what is table encoding? Okay. So she's asking for the difference between drop down and label. So we can say that they are the same thing. They are basically the same thing. Okay, so like I said, we'll end this class by 10. So we've basically completed everything. So here is just to bring everything together. So here is to filter. So the filter is just to, can somebody remind me the filter? What we did in the filter function? Yes, unwanted classes. So here we opened the file. So we read all the content of each of the files. So here we added the file name as one of the classes, which is like a categorical encoder. Then here we just built the data type. So if you run this line, it's going to give an error, and it's because we've already done the previous steps before. So it's just to put it together. So if you run this line, it will give an error because you've done it previously. So after that, so she gave a very good question. In that question, she said that when do we divide it into train, validation, and test set? So previously, in the last one, it was at the point of loading it. That's when we divided it. But this time around, is after we built the data type. That's where we now divided it. So can you look at this code carefully? So if I, for instance, if I tell you, so what this code simply means is that 80% for training, 10% for validation, and 10% for testing. Do you all understand what I just said? Okay. Thank you very much. Then, so after dividing it, then we build the data loaders. So what this means is that you are not going to load in all the data at once into the data set. So the batch by batch, you will load it in 128 by 128. I remember the formula I told you, 2 raised to power x. So what is the x here? 7. So that's how you load it batch by batch. Then after that, the next step is just to standardize for the continuous attributes. So that's what we've done. We got the mean, we got the standard deviation. Then after that, we use it to standardize. So because the continuous values are not standardized yet, so we've not standardized it. So that is to get it. So based on what we've done, then in the lab, we are going to continue from where we stopped. So So tomorrow, 5 to 6, we are going to continue from where we stopped. Yeah. So what we are going to continue with is we are going to build the model. So we've basically done what is on the top. We've basically done what is on the top here. So in the lab, why did we shuffle? Okay, so that's a very good question. Did we actually shuffle? That's the question. Did we shuffle at all? Did we shuffle? Yes. Okay, so thank you very much. So it shows that you are following. So it was at this point we shuffled. So thank you for raising that question because I didn't talk about it. So it was when we built, it was at this point. So at this point where we're trying to load it 128 in 128 batches. So that's when we shuffled. So thank you. That's a very good question. Thank you very much. So then after that in the lab, we are going to do this. We are going to complete this. So we'll stop here for today. So we are still trying to work on the time for the extra, because this is a 3-unit course. So we've not yet finalized it. We've not finalize the time for it. So maybe the class rep can come again to finalize it. But I want to have, because if to say I had these 2 hours complete for this week, I can just forget about the 1 hour tomorrow. But we didn't have the complete 2 hours, so that means I have to, that class tomorrow has to hold. So it's after that we can now discuss about how to find another time for the extra 1 hour. So there's town and gown. The HOD has come to call you people in